So what exactly is containerization? Because you may have heard this term being thrown around, maybe not, but it's used in DevOps. So kind of the deployment of your applications, it's kind of used primarily in there. Um, so let me get started by saying what exactly Docker is, because that's kind of the software we're going to be using today. So what is Docker? Docker is an open source platform that allows for the development and management of containerized programs. Now, what exactly are containerized programs, and how does it differ from a traditional program? To answer that, we need to understand what containerization is. Containerization is a type of virtualization that runs on the operating system rather than on emulated hardware as a virtual machine would do. So what the heck does that mean? So let me share my screen here. I have a couple images I just pulled up here. You guys should see the screen. And so what exactly you can, so this kind of shows us what exactly how containers work. And then let me also show up containers. There's probably a good image out there that shows the contrast between. So you have right here virtual machines. Now you might have heard this term being used before. If you've used Wayne State's virtual lab, I think it's this website right here. You could pretty much access a virtualized computer. So technically it's not really a computer, it's a emulated computer, and access it from wherever and use the software that Wayne State lets you use. Now the thing is that emulates, or that goes straight on through the hypervisor, which is pretty much like the it's hard to explain. I'm not very good at explaining, but pretty much it runs straight on the hardware. Virtual machines do. But the thing is with containers, the container engine runs on the operating system. So you're not actually running it through the same hardware or the emulated hardware. You're running it on the operating system. You're going to see how that works once we open up and install Docker engine. So this diagram just shows us that Docker is usually installed on the host operating system, as opposed to virtual machines. They're kind of they run on the infrastructure itself, which is pretty much like the physical machine. So within Docker, within the Docker ecosystem, you have all your containerized applications. So you're going to see that firsthand. Well, let me first say that some of the key benefits of containers are portability, right? Because the thing is, with a container, all you need for like your containerized application to work is Docker installed, because it's virtualized on the host operating system rather than being on the infrastructure. So you can't, like when you try, like let's say you try pulling something from GitHub, right? Like you try building an application, you have to install the dependencies, and maybe you have a compatibility issue. The thing is, with Docker, you could kind of package everything into a nice little container or in an image, and you're going to see how that works with this kind of thing. We're going to be building our own Docker images and then deploying our own Docker containers. So the key benefit, portability. You can pretty much run any Docker container on anything that can run Docker, and that's most systems. They're lightweight, so a Docker container, instead of emulating the entire infrastructure like within the hypervisor, which is very resource intensive. You could see the app runs on the libraries, that runs on the guest operating system, that runs on the infrastructure. Thing is, with the containers, the app just runs simultaneously within the container engine's ecosystem, and that's nested within the operating system. So you don't have to boot an entire guest OS. It'll just be a part of your operating system, which is, so it's like a universal, I don't know what a JVM is.
Oh, sorry, Java virtual machine.
What is a Java virtual machine? I've never heard of this.
It's what Java runs on. That's why it's kind of like run anywhere.
Yeah, I guess it is like that. Yeah. Yeah, as long as it doesn't emulate its own hardware, it seems like it has its own ecosystem. That's like, yeah, that's a good analogy. I guess. Yeah, never heard of that. Sorry, but yeah. So it pretty much you can save so many resources by not having to run this guest OS. You just run it straight on your engine. What else is there? So it's lightweight, so it takes less time to boot up these containers. Microservices. So we're going to be, I hope we get there if we have enough time. We're going to be using Docker Compose. So Docker Compose, let's see if there's a good diagram out there. So this is a very important tool. I guess, I don't like this image. Yeah, I guess, no. Okay, I mean, I guess there isn't really a good diagram for Docker Compose, but Docker Compose lets us utilize microservices, which allow us to run multiple containers that can talk to each other. So you can have, like, let's say in this instance, app 1 and app 2 within their own stack or compose. Like if they're composed together, they can talk with each other. And you're going to see how that's beneficial, because let's say you have your app 1. Let's say app 1 is a database. Let me draw this out. Just this makes, because I'm just kind of talking. But let's say like app 1. Actually, I'll just call it, like, let's say this is our node, or I'll just gonna say Python web server. So let's say this is container number 1. And then let's say we have another container here. And try this. Sorry about my handwriting. Container number 2. And then this will be like a database. So for our case, I'm just going to say MongoDB, which is a NoSQL database. We're going to be using this later on. And this is a database. DB stands for database. So if we were to, so let's say this was like, so this is all under like our Docker engine. So it's within the Docker daemon. So a daemon is pretty much like something that runs in the background of your computer. So you can have these containers running in the background of your computer. Now in a server environment, everything kind of runs in the background because there is no really foreground if it's a headless machine. But this is within the Docker environment. So let's say if this was in a Docker Compose, so pretty much what Docker composes, you can kind of bundle this up together and call it a, like, let's call it stack number 1. And if you were to call this stack, and I'll show you how we do that. Let's say you were to call this stack, it will automatically have a link between these, and it'll allow the Python web server to communicate with this MongoDB web server or MongoDB database. So pretty much if you were to call these together through Docker Compose, you would pretty much be able for these to talk to each other while kind of maintaining the secrecy. Like it'll be on its own. I don't know how to explain this, but it's just pretty much linked together. They have a very close link, and it's since it's within this Docker environment, no one from outside can theoretically get in. Obviously, hacking, however that works, right? But theoretically, because Docker emulates its own network devices, and if you were to call a stack together, by default, any containers in the stack will be isolated from the host network card. And you'll see that, I think I can, let's see if I can pull something up here. So Portainer is kind of like a, over the summer, I'll just give you some background. I had the pleasure of learning Docker and migrating all my services to Docker. It's honestly been one of the greatest things I've ever done. So Docker allows you to have, so this is Portainer. Portainer is pretty much like a web interface for Docker. It's pretty nice. So if I were to show you like stacks that I'm running, so like C-File is kind of like OneDrive, but like open source. So you could see like C-File Compose, right? This is a Docker Compose that I've already composed, and this is under a stack. So it's running these 3 containers simultaneously and they're isolated. And so they run on their own network. If I were to click on here, yeah, you can see this is running MariaDB, which is like MySQL. And then you could see this is just like it's running memcached. Let's see what else I can see here. Try to go to the bottom. I was just trying to find the whatever it is. Okay, whatever. Yeah, but pretty much you can have like networks. Like let me find it. And networks, and you could see that. Where is it? Like, yeah. So this is a composed network. So it's pretty much a composition of 3 other containers that are in this network. So you see that this stack has its own network. Okay, this might be a little confusing. I'm just going to stop, but I hope you get the gist of it. So what we're going to want to do now is, I guess we can get right into it. One more benefit that I forgot to mention is scalability. Docker Swarm is pretty much like a combination of multiple Docker instances across devices. And so that allows you to do load balancing. So if you've been studying, like if you've been doing interview prepping, you have to also do, I forgot what it's called, but you have to learn system architecture and that kind of stuff and how you deploy applications. Load balancing is a very big, it's a key word. It's a key principle that you learn when you're doing that interview prepping for when you go down the line to try to get a job. So Docker Swarm allows you to load balance. Pretty much what load balancing is it allows you to balance your load. Like say like one container has a heavy load of like it's getting a lot of requests from other services. You can kind of duplicate, like let's say that container somehow goes offline because it was overwhelmed. You can have another Docker instance on a separate machine, start up the same exact container, and it'll just pretend like nothing happened. Like the user, the main thing is that the user will never experience that interruption. So it helps with load balancing, and that's very good for like, your application. You get a lot less downtime, which is very important, as you may know. So let me see. So let's get started. So how many people do we have here? Okay, so I think, let's see. So I don't know what kind of machines you guys have. So installing Docker, I'm going to be honest, it's pretty painful. So I went through the hassle of running of doing a kind of virtual machine kind of situation. So I have 4 workstations right now. 3 of them are Ubuntu, which is just like Linux. And then one of them is Windows 10, which I plan on installing Docker on here to show you guys how to install it. So if in case like, I don't know what kind of machines you guys have. Installing it on a Mac is different than installing it on a Windows, obviously. Let me find the website for installing Docker. This website right here. I'm going to send this over. We're going to try to go through it together. If you're on a Mac, here are the Mac instructions. Try to follow along. If you can't figure it out, use this website. And let me send it. Let me write this down. So yeah. So if you can't figure it out, use this resource. Pretty much it lets you like connect to a virtual machine. So this already has Docker running. I apologize if it's a little slow. This is on my home network. So let's see. So it should be running fine. But you don't have to install it. I'm going to go ahead, though, and show you guys how to install it. Just because, in case you want to do this yourself. I just don't want to force you guys to install something you don't want. So please utilize this resource. Let me send this. And then the username is VM user. Password is dev. Here. You guys can log into there. So I'm actually going to, let's see here. This is called. It's this. Get it right. Okay, good. All right. So let's go ahead and try to install it. Again, if you don't want to install it or you can't figure it out, there's 3 VMs. There's only 4 of us, 4 other people. So I guess try to install it, or I guess it's first come, first serve. Because yeah, am I ready? Okay, no, yeah. So go ahead. I'm going to go ahead and get this installed. Install Docker on this Windows 10 machine here, and this is a virtual machine. So what I'm going to want to do is for this to work, you need to have virtualization enabled in your BIOS. So okay, yeah. So to do that, let me find this picture I have. Yeah, you're good. So for me, I had to, I'm not telling you to do this, but I'm just going to tell you what I did. I can't even install Docker on my main computer, this computer here, because I have a lot of issues with it. I'm kind of transitioning from Windows to Ubuntu. I'm kind of sick of Windows. So not a lot of things work right now for me. So I'm just telling you, for your own computer, go to your BIOS menu. And to do that, you just, when you start it up, you have to like press a hotkey. For me, it's delete. It can be F12, F2. I hope you guys are familiar with this process. If you're not, again, we have virtual machines, but yeah. So what I'm going to want to do is I had to go to CPU features under overclocking. It's different for everyone, of course. You go to CPU features, and then under CPU features, you have VTD tech. That's pretty much like virtualization tech. I mean, I don't even know what VTD is. Let's see, actually, I'm kind of curious. What does VTD mean? Virtualization technology for directed IO. So I'm assuming that's for pass-through of like physical hardware. So you need both of these things on Intel virtualization tech and Intel VT tech. Both of those enabled. If you're on a Mac, I forgot the kind of thing. I don't even know if anyone here is on Mac. Let's see what they, seems like a lot easier. You have to follow these steps, but I'm going to pretend like we're all on Windows here just for the sake of this, I guess, tutorial. So once you do that, since this is a VM, I already have like nested VMs working. So what I'm going to want to do is, so assuming that's already done, so I don't need to do this on this virtual machine. So CPU settings, okay, so I did that. Yeah, so once you do that, you have to restart your system if you go ahead and do virtualization. And if I'm going too fast, or if you have any questions, please interrupt me. Please do that. Okay, so what I'm going to want to do now is I'm going to press this search and search for features. And this control panel, actually, let me full screen this. So turn Windows features on or off. So I'm going to click that, and over here, what we want to do is we want to enable a couple things. So I'm going to scroll down and look for Windows Subsystem for Linux. So this kind of allows you to run a Linux container on your Windows operating system. So it's not really like a virtual machine. It's more so, at least this specifically, this is more so running a container of Linux. I believe it's a type 2 hypervisor, which means that it runs on the operating system rather than emulated hardware. So we want to enable that. So Windows Subsystem for Linux. And we want to enable one more thing here, the virtual machine platform. We just want to enable that one too. I'm going to press OK. It's going to do searching for required files. And again, if none of this makes sense, or you're on a Mac or whatever, you have the virtual machines, please utilize them. I spent a lot of time figuring out because I had some issues with this. But fun fact, this website's actually running on Docker. Docker is very powerful, and it's running a Docker Compose for this version of the remote kind of manager, for virtual machine manager. So I'm going to do that. So it says Windows completed the requested changes. It needs to reboot the PC. So I'm going to restart now. This session is going to get disconnected. Any minute now, it'll be like, oh, yep, it's gone. Okay, so I'm going to wait for that to restart. In the meanwhile, you guys can, what's it called? I guess we'll just wait for now. Again, any questions, interrupt. Yeah, the VM link here. I can send it.
Yeah, when I switched to computer, I lost chat.
You're good. You're good. I got you. Yeah. If whoever's used, don't do the VM4. That's the one I'm using. Once I set it up, whoever's wants to can use that if you want. But the Ubuntu ones are also fine too. They have Docker installed. So let's see if that rebooted yet. 1 second. I'm just gonna check. Okay, it's still updating. You can see like on your when you do this yourself, or if you do it yourself on Windows, it's gonna think it's an update. So you're just gonna want it to let it work on that update. And I hope it doesn't crash. It's been very unstable, at least Windows has. But other than that, once you do after that, you just install Docker Desktop, and you have to do like one more thing. And you have to update the kernel, and then it should be done after that. So hopefully this doesn't crash. So I don't know how long it's going to take. It's very slow right now, but yeah. Let's see here. Let's see what I can say in the meantime. Nope, it's okay. There we go. I'm gonna open up browser, and I'm gonna paste this URL here. This is the Windows Subsystem update. It's not an executable. I lied. It's an MSI file. Very similar. So I'm gonna let that run, and this should update my Windows Subsystem for Linux, and that should prep it so that I can run Windows Subsystem for Linux version 2, and that would set us up for downloading Docker Desktop. So while that's doing that, I'm just going to install Docker Desktop. So that's Docker Desktop Windows download. That's fast. Okay, and this download just finished. Okay, and I should have given this a little more power. I'm going to run this file. It wants to do that, and oh my goodness, this is very slow. I can give it some more power, but that will change after I reboot. Okay, so that's going to start updating, and yes, the update, yes, next. Let that do its thing, and then I'm also going to download Docker Desktop while it's doing that, just so I don't have to wait, because this is being half a gig. So yeah, running two things at once. Okay, it's done. Now I'm going to download Docker Desktop for Windows. And before I do that, I have to set my Windows Subsystem version. So to do that, we're going to go to PowerShell here. And I spelled that wrong, but it doesn't matter. I'm going to right click and run as administrator. Wants to register that. Okay. Yes. And I'm going to run this command here in just a second. There we go. Okay, and let's see if this wants to load. Man, it's very slow. Okay, so I'm gonna run this command now. WSL. Okay, there we go. Okay, it's just very slow. Okay, set default version 2, so that'll use WSL 2, and oh man, there's another reboot after this, I think. Let me make sure if I have to reboot again. don't think I have to. I don't know why I wrote that down, but what we do need to do, I think, it says it over here. I'm not actually sure if you need to. We'll see. We're going to run this setup and see if the setup is complete. And you just finished, so yeah. So I'm going to run this. I love Windows. Okay. It's froze. No. Oh, I'm doing it again. No, I don't think so. I need to do it again. Yeah, so I'm gonna Control J here, and oh, there we go. Finally, yes, I'd like to run this as an administrator. So this Docker desktop pretty much is like a user-friendly version of Docker. So Docker originally is a command line tool, and in my opinion, it's a lot better through the command line, just because everything is in. I mean, I don't know, command line's just better for a lot of things. Docker desktop isn't perfect in a lot of aspects. Is my main reason. But it's a good way to get into the Docker ecosystem and try to learn everything about it. There's also what's it called? Kubernetes, which is like Google's version of Docker, kind of. I'm not even exactly sure, but I've heard Kubernetes is like, yeah, it's a way to maintain or manage containerized application. Yeah, it's by Google. So those could work hand in hand. Yeah, you could see Docker is very similar in that sense. And you're going to hear this thrown out a lot in DevOps because a lot of the industry uses Docker and Kubernetes. Pretty good stuff. Let's see. Did I even run? Let's see why this is so slow. There we go. Install this on the SSD. This is insane. I don't even know what's killing it right now. In case anyone wanted, this is the install page. And I'm just going to let this install. I don't know how long it's going to take. Hopefully not too long. Okay, hopefully this does it in due time. I don't think I'm gonna. It's gotta wait for Cortana to re-enable itself. Yeah, I love Windows. Honestly, I think I'm just gonna join on my laptop here. I just wanted to show the installation process. I don't think actually deploying anything. Okay, never mind. Hold on, let's see. Yeah, I'm gonna want to use WSL2 instead of Hyper-V just because I literally just installed I just enabled WSL2. Hopefully it works. I'm gonna let it do that now. Gotta love how fast this is. see if I can start prepping. Can't do anything while this is. Oh, installation failed. Let's see. Don't even know what that is. When I quickly Google this error, if it's something that is takes more than 5 minutes to fix, I'm just going to go on my laptop because I have it installed there. Let's see. Part of doing this kind of stuff is that there's always issues. Let's see here. Install old version. See if there's a solution. Oh my God, I don't want to do all this. I'll run it one more time. If it screws up, I'm throwing the towel. But hopefully, like that's all you have to do pretty much. If you were doing this by yourself, you would just install it after you set up your Windows subsystem. You pretty much just install it yourself. It should work. I'm going to join on my laptop here real quick. Let's see. Where's a good place to put this? I can't even remote into it, which kind of sucks. It's move my mic here so I don't go too far away. Okay. This is gonna kick me out. Okay, good. There's two of me. All right. You guys can still hear me, right? Okay.
Yeah, we still got you.
Thank you. All right. So I'm gonna share my screen on my laptop now, just because this is just gonna take too long. I don't want to waste your guys' time. So, but ideally it would work. I can't share my screen. This is my laptop here. Okay, so I have Docker desktop. Let's just pretend like this was a seamless installation. It wasn't seamless when I tried it on my main computer too. So I hate Docker desktop. There's always weird issues. If you use Linux, if you use any sort of distro of Linux, Ubuntu, Debian, I've never had any problems. It always works fine because it's Docker is best used in Linux. That's just a kind of axiom for you to follow. But I'm gonna open up Docker Desktop now on my laptop. I have the Windows subsystem for Linux, and I'll show you what that is exactly. If I were to just, I don't have a mouse. I'm just using my touchpad. But pretty much, it's like if you open up your terminal, you have the ability to open up like a kind of like a Ubuntu shell. So it's pretty much like a containerized version of Ubuntu, and this is technically like a container. You can see all the stuff that's running. You can see Docker is connected. You see all these Docker processes. That just pretty much just shows that Docker is like working on this same like Linux container, because that is how Docker works. It kind of goes off your thing. So what's this? What was I doing here? I don't even know what I was doing here, but man, this must have been from a while ago. So I'm going to clean this all up, actually. So these are all just containers. I'm going to delete all these. Hopefully none of these are stuff I actually need. It's been too long. But yeah, so again, if you don't want to deal with the problem, there's or like the issues with that, there's one more VM left. You can use that or just watch, doesn't matter. But what I'm going to want to do is to run stuff. Again, I hate Docker Desktop because it just tells you to run stuff in the terminal regardless. So I'm just going to open up command prompt here. Excuse me. And we're just going to do a hello world in Docker. So to do that, I keep using my mouse like it's on my computer. So, but to do that, what we're going to want to do is Docker run hello world. So hello world is an image. So if you were to like do Docker run by itself, it would tell you you need something else. You need the image as a parameter. You can have options too for running. I hope my mic. I hope you guys can. It's not awkward. Let me actually move my keyboard here. This sounds better. Okay, so yeah, you have Docker run. You have the like options, and you have the commands and other arguments. But to run it simply, Docker run hello world. I don't really need any arguments for running something as simple as this. So again, in case you don't know how to get to your terminal, you search up command prompt on Windows. It's there. On Ubuntu, it's just terminal. You just right click on the desktop and you press open in terminal, I believe. It should be pinned on the taskbar, which is on the left side. It looks like a little terminal. That's how you open your terminal, and this should work. Let me know if you can't figure it out. But so what we do is Docker run hello world. I'm gonna press enter. It can't find hello world locally, so it pulls it from Docker Hub. And what Docker Hub is kind of like GitHub. You can see it actually tells you the steps here. So it says Docker client contacted the Docker daemon. That's kind of like what's running in your background, like Docker stays running in your background. It's actually pretty resource intensive, but it's a pretty good trade-off for compatibility and scalability and all the other benefits of Docker. You can see kind of if it shows up like virtual memory, there it is, vmem. This is like my Docker, like it's using a gig of RAM. Not that much CPU, but it's just using a gig of RAM. That's virtualized memory that's using container. And this laptop is not that powerful, so it's going to have a little trouble running it. But you can see hello world worked. Like it says hello from Docker. And then what was I saying? Yeah, so it pulled hello world image from Docker Hub. So Docker Hub, again, is like a Docker Hub. It's pretty much like GitHub, but for Docker images. Now, what is a Docker image? Pretty much it allows you to, like, it's kind of like a single file that packages the entire application, like whatever application. So there's one for MongoDB. We're going to use that for our Docker Compose example once we do that. There's Redis 2, which is like another database kind of thing. There's one for JDK, which is Java Developer Kit, I think. NGINX, that's one of the examples we're going to use. NGINX is one of the most used kind of web servers. I think it's very popular web server, and it's used every day in a lot of websites. Nextcloud, that's something I run personally. It's kind of like Google Drive, but open source, and there's a really good Compose. You can run like your database and the Nextcloud application all in one Compose file. It's pretty nice. You can run Python scripts. So our first example, we're going to be building our our Python script. So assuming I don't have Python installed, so one of the beauties of Docker is that I can pretty much run a Docker. I can pretty much run a like Python JavaScript script, a program, without having Python or JavaScript installed on my host machine. It'll install it through Docker itself, through the Docker container rather. So to do that, and you can see, by the way, since I did that Docker run, there's a container here that's currently closed because it just exited. It's just one output. So you can see like the response there, hello from Docker. That works fine. So let's go ahead and get started on our first example. So let me go to my desktop, and I'm just going to create a new folder called, let's see here. Let's see, new. And then this will be called, let's just call it Docker Python. And so what we're going to do here is we're going to run a Python script through Docker, and it won't even use my personal installation of Docker or personal installation of Python. It'll be using the one that gets installed in the container, and that's all managed through Docker. So I'm going to open this. I guess not open this in VS. This is annoying. There we go. Okay, so I'm gonna open this in Visual Studio, which is the code editor I use. You can use whatever you want, but yes, I trust the authors. And I'm gonna create a couple files here. So I'm gonna first create a what's it called? A data.txt file, and man, that's slow. Okay, and I'm also going to create a Docker file. You can see the whale icon shows up. It recognizes that it's a Docker file. So what exactly is a Docker file? It's pretty much like a set of instructions that will get run upon building your Docker image. And when you build your Docker image, that's pretty much like that'll allow you to run the containers through that image. Like, remember when I was running the hello world script, or the hello world image, it asks for an image right here. So Docker run image. Potentially we'll be able to run our own image once we build this Docker file, because once you build a Docker file, you get the image. So we're just going to keep that empty for now. We're going to write our script first. So our last file is the main.py, and this will just be a simple Python script that'll show off. Why is this so darn slow? I don't even know what it's doing. What does that even mean? Okay, whatever. So I'm going to have just a very simple script here. What it's going to do is just it'll print out the operating system of which this program is running, and yeah. So I'm going to do import SYS, so import system. That's pretty much what that is. I'm also gonna add something in here. Hello from Python. So I'm also gonna print this file out, because I'll show you can add your own files to Docker images. Add your own static files, of course. We're also gonna be adding our source files into this Docker image potentially. So in here, I have in the data.txt, I have the hello from Python, and then in my Python file, I'm going to do file contents. So I'm going to read that file, the text file, open data.txt, and this will be a read. That's what the R is. It'll be like reading it, read permissions. And I'm going to call the read function, so that'll turn it into a string. So I'm just going to say read text file. Okay, and then I'm going to want to print everything out. So I'm just going to do an F string here. And let's say like platform. So we're gonna print out the platform. So the platform, or the operating system, I guess. So it'll be sys.platform, and I'll show you what that output is. And then new line, I'm gonna say like we're gonna do like string of file contents. Nope, that's not what I wanted to do. String of file contents. So if I were to run this right now, you'll see that Python installed. That's definitely not true. Python 3. Oh, okay. Well, I thought I had Python installed on this computer, but I guess I don't. But oh my God, I really don't. Okay, but if I were to run this on my host machine, if I were to run this on my host machine, this would print out Win10. So system.platform, its value, if I were to run this on my Windows computer, would be Win10. And you're going to see when we run this through Docker, the platform will be Linux. So just take my word for it. If I had Python installed, it would print out Win10, which is short for Windows 10, of course. So let's do the Docker file. So a Docker file, again, is a set of instructions that'll allow us to kind of build our Docker image. So to do that, we're going to want to take a reference image. We always want to start with some sort of reference image. So again, we had Python here. We're going to use Python as our base image, and because we want to be able to run our Python script in the end. So to do that, there's a ton of versions you can use. And there's terminology you'll see if you use Docker down the line: Alpine, Buster, Bullseye, Slim. Pretty much, I forgot what they mean, but a lot of them are optimized for different kinds of Linux. And so you would use that the functionality doesn't really change, but the image will work better running on containers if you change it to whatever it's optimized to. So like there's one for Windows Server Core. So obviously that would work. It would be the most optimized when you deploy that code that you're making for Python if you just change it to Windows Server Core. So it'll just run better. And that's like a one little change you could do before like your pre-deployment. So it's not that big of a deal. But the base image I'm going to use, since this isn't too crazy of a like script, I'm just going to do to do your what's it called, your reference, your base image, you want to do from, and then we're going to do Python, and then 3.8.3. That's just a very basic version. You could do 3.10 too. It doesn't matter. I just have this written down. I also want to have a work directory. So this is where your code is. Like this is where your this is the directory in your container, not your host machine. There's an important distinction we have to make when we're working with directories, and you'll see this when we do our Docker Compose example. Directories on your host machine and the I forgot the other term, but it's in your containers machine. So I'll show you what exactly that distinction once we add static files. But our work directory, it refers to it says it right here. Yeah, it doesn't say exactly, but it's within the container. So it's like whatever is in the container. Like this will be the default directory. That's, for lack of a better word, default directory. So I'm going to do /root because that's like a pretty good default directory when you're dealing with Linux. And I'm going to want to add so now what we can do is we can add our source files and static files. So to do that, I'm going to do add. So remember the thing, it says it actually right here. So source and destination. So yeah, that's the word I was looking for. So source is pretty much like what's on your local machine. Destination is what's going to be where it's going to be thrown. So it'll be thrown in that container at this location. So obviously I want all my code to be thrown in the same directory as the work directory. The work directory. So I'm going to do data.txt. And then the second argument is /root. And I'm going to do the same thing for my main.py file. All right. What is this highlight? I don't even know what that is. Oh, you don't even see that. Okay, whatever. Now what we want to do is we want to actually run the Python file. So there's multiple ways of doing this. There's entry point right here that can be an executable. But since this is kind of like a one-time thing, like you use entry point, I'm pretty sure you use entry point when you have something you want to keep running. So let's say you build a Node.js web server, you would have an entry point that would pretty much like run constantly, like it won't stop. What CMD does is it just runs it once. It's kind of like a one-time thing. That's all it is. And so this is an array. And what we want to do is our first thing is the executable and then the parameter, right? Like it says right here. So our executable is just Python, right? Because when I was trying to run it here, as you know, in the command line, it says Python. It wants to run the Python file. Like whenever you run a Python file or a Node file anywhere on a system, it always runs this in the background. Maybe you're not used to it if you use like idle or whatever, but it runs this command in your command line and just sends you the output. But if you were to break it down, this is the actual call to your system. So Python and then the file. That's kind of how it works when you're dealing with the command line, in case I haven't explained that good enough. But Python and then the main.py. So since we're in the work directory, like that's the default directory, we can just refer to it as in the same directory. You could also just do /root/main.py because that's where this file is located. Either one will work. I'm just going to do main.py because that's implied it will work. So this is a one-time kind of thing. It'll just run and it'll send us the output. So to actually build our Docker file, now what we can do is, I guess I can just do it here. Close that out. And those virtual machines, what's it called? They do not have any sort of Visual Studio. I'm sorry about that. You're just gonna have to use whatever is default. But pretty much what you want to do is you want to open up your terminal. In that same directory, you have your files, your data file, your Docker file, and your main file. And what I'm going to want to do is do Docker build, and then dot refers to this current directory, refers to the directory we're currently in. And I'm going to give this this image that we build a name. I'm going to call this Python test, so py test. So remember, dot is this directory that we're currently in. Like, I don't know if you've ever seen it before, like cd dot dot, that goes back one directory. And then cd dot, that does absolutely nothing because that's the directory you're in. That's just some terminology there. So now I'm going to do Docker build the current directory T, and then that's the tag name of the Docker file, and then the name of it right after. So I'm going to run that. It's going to start building it. So you can see it looks pretty cool. It's, what is this doing? So it's looking for the Python library. It's downloading it. It's making sure it's like verifying that this is like the actual thing. And it looks pretty cool. So we're just going to let that build. It's kind of like, kind of reminds me of like when you're building something with like Maven, or like when you're doing like what's it called, Java development with like you're compiling like your app, your Android application. It looks kind of like that in my opinion. But we're gonna let this build. It's probably gonna be slow just because my laptop's internet card is very slow, so it's downloading things very slowly. But usually it doesn't take too long. One of the downsides of this is, since you're encompassing, could you go back to the main.py? Yeah, sorry about that here. I hate this thing that's in the way here. Yeah, so let me zoom this out. Yeah, okay. Yeah, but one of the downsides of kind of doing Docker images and just Docker in general, it's, oh shoot, hold on, my headphones just turned off. But one of the downsides is because you're encompassing, you're pretty much downloading the entire like Python library or whatever library. What happens is it's very like, it takes a lot of space in terms of like digital storage, because you're taking the entire Python like library for in our case, which is like almost a gig, at least Python 3.8.9 or 8.8.3, and you could use the slim versions. I'm just doing this for the sake of the example, but it does use storage. It's a very storage intensive. So yeah, so it just built it. It named it to PyTest, py test, and now I should be able to see it. Docker images, I think that's the thing. Yeah, so I have a lot of images here. I don't really remember exactly what, but you can see this image. If I were to type Docker images, right, you could see that this shows up that I just built it 18 seconds ago, and you could see it's almost a gig. It kind of sucks. Same with Node.js. That's a gig too. So it's pretty like, and so for each container, pretty much it uses like a gig. It's a lot, but it's, you know, it's all in for the name of redundancy, right? That's what Docker does. It's a very good it's very good in terms of reliability. So that's kind of a sacrifice we have to make with it. So now, how do we run this Docker image file? How do we put this in a container? So there's kind of ways of doing this. I'll just first show the Docker desktop way. Excuse me. So I'm going to go over to images, and you should see, again, I have a lot of stuff here. I don't even remember, very long time ago. I don't even know what BusyBox is, but anyways, you should see Python py test here, built less than a minute ago. That's the one we just built. So I'm going to press run, and let's see here. You can give it some optional settings. I really hate the GUI personally, but you could see it runs. It's a random container name too, and it run and it exited. So I'm going to go over to here and click view details, and you should see like this is the output from that Python file. Like it's the same thing, trust me. And you can see the platform's Linux now, and it says hello from Python. That's what that text file was. So pretty much what happened is it ran the file, the Python file, within a virtualized version of Linux, virtualized version of whatever Python's base image was, right? And which is probably, Linux, hence why it says Linux. So if I were to, again, remember, if I were to run the same Python file on my host machine, it would be a different output. It'll say Windows 10 because that is the host machine, but you could see that it's now different because you're using that virtualized service. You're running it through Docker, which is all virtualized. So that's a pretty good, like you can see, like it's pretty good. And I'll show you how to run it through the command line. It's a lot easier in my opinion. Docker run the image name, right? Remember from last time, or remember when we were running Hello World, it's literally just this. And you could see, boom, just like that. Same output, a lot less steps. And you'll see the container, it spawns a new container because it says just spawn this new container. So you have to realize, it's this one, you have to realize containers, think of containers as processes, not virtual machines. Even though they might act like virtual machines, they're more like processes. They're more like processes that run on your system because of how disposable they are. Like it runs and it's gone, it's done forever. That's something that I had trouble thinking about too, because it's kind of weird. It feels like a VM, but the technology is completely different. So you can see that works. So now we can get over to doing our second example, and then there's one more example after that. And yeah, so any questions before we move on? I know I kind of rushed. I hope I didn't rush too hard, too fast. Please interrupt me. I'll try to get this ready.
And I assume at build that is that's completely independent from that file dev. So if you were to say completely hypothetically, forget the quotations on data.txt, you'd have to rebuild the whole thing.
If I were to forget about what?
In order to make changes like programs or files, you would have to rebuild the Docker thing.
Yeah,
right?
yeah. So there's actually multiple ways of doing it. So since Docker can be used to for development too, I know a lot of companies that are doing that too, just because they have a ton of dependencies that are very strict in terms of their hardware, their requirements, whatever. You can actually do live development, and that's to do that. So the problem, the issue that I'm glad you caught up on is you have to add it to the image each time. So that means any change you'd have to do, you'd have to build a completely new Docker file, which is just absolutely, it's not good for development. It slows you down in development, especially how long it took. So there's these things called bind mounts, and we're going to use those actually in this example. So bind mounts, I should have said Docker, but pretty much what it allows us to do is use Active Directories from your host machine into the Docker area. So I'll show you how this works when we build our web server, and you could be able to make changes in real time. How would that work with a database image? So a database image, again, very good question. The thing is with a database, the database uses bind mounts themselves. So if I were to show you MongoDB Docker image, we go here. There are bind mounts within the when you run it, like on runtime. So if I were to show you, where is it? So this is a Docker compose file. We're gonna do that at the end, and those are very powerful tools. I just want to see if there's so okay. So this right here so remember we were running our Docker image, Docker run PyTest. You can also have other properties like name, that'll name the container, of course. And there's this one special property that's very powerful called -v, which is volume. So you can actually use your own volume, and this is a bind mount. So you're actually binding it to your host computer and binding it to this directory here. So all your changes that you make in your database would be stored within this directory on your host machine. And this is the essence of what's it called? Persistent storage. So that's like a very big principle that I forgot to even touch up on. I'm glad you guys said that. Persistent storage. I don't even know if I spelled that right. Storage Docker. So that allows you to keep your storage or keep your data secure, and also persistent, so it doesn't delete after, or you don't have to make changes each time. So again, this is the same thing, but you could see that like there's different kinds of bind mounts are one way. So bind mounts, again, let me reiterate, that it pretty much uses the directory on your host machine and stores the files straight up from the container. So it's very good for like using bind mounts is very good for for your database, because you can easily make backups by just copying that directory because it's on your host machine, right? So you can easily just copy that. You don't have to go into the container and look at the files that are inside of it. It's within within that within the file that you defined it when you ran it. There's also Docker volumes, which are like kind of like images, but they're volume files, and those are you could save data in a directory on your host machine, but it'll be like one file. So if you want to send your volume to like another developer, another software engineer, you would just copy that file and give it to them. With a bind mount, you would just have to copy that directory. You'd probably want to archive it or somewhere, like zip file, put it in a zip file, because you can't just send a directory easily, at least through the internet. So volumes are very good because the whole point of this is for portability. Docker is very versatile, so it allows you to like use these kinds of things, bind mounts, and we're not going to be using volumes. Personally, I don't like them. I mean, they have their applications, of course. I just haven't found an application for them because it pretty much just stores everything in one file on your host machine. But it's like an image in terms of like if you've done stuff with VMs, like when you create a virtual disk image, this is kind of like that. I would like to think of that like this. It's just one file, and then inside that file, it's kind of like an archive of all the directory. So I hope that makes sense. We're gonna get into that example and show what bind mounts are, so you don't have to keep building your image for every new code change. So let's get into that. And does that answer your question? Hopefully, let me know if it doesn't. So I hate this thing that's in the way. Okay, I'm just going to move this to the bottom. Okay, so I'm going to run a, I guess we can use this same directory. Let's see here. So the next example we're going to do is a, what's it called? It's going to run NGINX. NGINX is pretty much like a, I'll just show you guys on Google better. NGINX. It's pretty much like a very fast web server. It's very versatile too. And so, yeah, HTTP cat. It's got a lot of features. It's a very good web server that's used everywhere. Like it's used everywhere when you're serving files, pretty much on the internet. And this is how a lot of like companies serve their files. They use NGINX or Apache. Webserver, whatnot. There's different ways of doing it, but again, NGINX is very popular, so we're just going to use that, and we're going to use bind mounts for this. So in here, I guess I'll make a new folder, I guess. This is really annoying doing this on a touchpad, but I'm going to create a folder here, and I'm going to call it website. And in here, I'm going to want to open this up in Visual Studio and create a couple files. I guess I'll just create a sample website. So we're just gonna like run a website, and this won't be like a one-time run. Like you could see with these images or with these containers, once you run them, they stop instantly. This will be running on our daemon. So the one that we build, like this NGINX thing that we do, it'll be running constantly, and it'll be running in the background, and that it's going to utilize the Docker daemon. Pretty much a daemon, I don't know if I've explained it yet, but pretty much what a daemon is, it's like it's pretty much what runs in the background of your computer. I actually did explain that. Okay, just kind of forgot. So let me do, I'm going to create an index.html. Now, if you have any experience with web development, maybe you'll know that index.html, that's pretty much like the root of a directory. Like that's the page that gets served at the root of a directory. So we're going to be serving this HTML file. So I'll just build like a sample website here. You need our HTML tags. Sucks that they're not auto completing. Head tag, of course, and title tag, right? There it goes. My NGINX, I'll just call it my website. And I'm going to create a body. And that's where our body is. We'll see like H1 or H2 and be like, welcome to my site. Again, very basic stuff. I'm just building this for the sake of it. And then we'll have a p tag saying like, this site has been served by Docker. Okay, so now what I'm going to want to do now is I'm going to open, I'm going to do F10, open this in the console, right? And what's it called? So again, just CD to your directory that you're working in this on, so that this is the directory I'm in. So I'm going to do Docker, you know what, I'll make this a lot more simple. So I'll have like a, say run.bat. So this will be a batch script that'll work on Windows. Don't try to do this. If you want to do this on Linux, call it a run.sh. You know what? I'll run this on. I can run this through Linux actually. I'll try to, right? Because I think Docker works, right? Okay. Wait, let me just check. Okay, yeah, that right. I mean, okay, there's definitely more than whatever. You'll see it work anyways. So I'm gonna use what's it called? So yeah, I'm gonna rename this to an sh file so that it'll be just like in Linux. If you're on Linux, you can just follow along now. So what this run.sh file, it's gonna run our NGINX web server. So to do that, remember how we were running previous things through Docker? We were doing Docker run the image name. So I'm going to start that off here. So Docker run, and I'm going to do -it. Forgot what this does, but you need it. --rm. Don't know what that does either. You know what? I'll make sure of it. I think rm is just remove, or it might be something else. Let's just make sure, because I just remember. Okay, remove the container when it exits. So pretty much, I actually don't want that. That sucks. I want to keep it so I can restart it after. And then what does IT do? What is the IT option? Okay, so that just means you can type in that console. So I'll just keep that there. And then I'm going to want to do /d. So what /d does is, again, these are just flags that I'm putting in. So this flag right here just makes it so that I can type in the console or something like that. /d, what this means is like daemonize, like it'll run in your background. So if I were to get rid of this, it would just be the constant, like I'll show you, I'll actually show you. But this just allows us to run this in our background. /p or -p is our ports. So I'm going to define the ports that we're running this web server on. So I'm going to do 8080 just for the sake of this example. And so remember, actually, I don't even think I explained this yet, but pretty much whenever you're dealing with stuff with like Docker, like just anything in general, you have a format, and like the format, usually if you have something : something else, like you'll see this a lot in other examples, you have something like a host port, for example, or maybe this could be like a mount port, and you'll see, and then you have like the container port. So this will be our host port. So it'll be serving the web server on port 8080. And we're going to, and by default, the container, like the container when they built the NGINX web server, the container default serves through 80. So it's actually pretty nice. You can route all your traffic from the container from port 80 into port 8080 on your local internet card. So, or I just locally, I guess, not your local internet card. You could serve it locally by doing 0.0.0 : which allows you to any other devices on your network or on your NAT to access this web server. But I'm just going to keep this simple for the sake of it. So pretty much on our host machine, port 8080 is what will be served from our web server, from the container. So I'm going to give this container a name, and the container name will just be called web. I'll just call it web. and then dash v. Remember this is a volume, so we're defining a volume. So instead of manually adding, and again, you can use a Docker file. The only reason you don't need to use a Docker file is just because you can use these passive. Mainly is because I don't have to like change the code of the web server, right? But you could use your source code as a pass through these bind mounts. I've seen people do it. It's pretty normal. It's good for development, right? But for the sake of this, we're going to use this pass through or this bind mount so that I can serve this index.html. So in fact, I'm actually going to call this, I'm going to create a new folder just because I have this run.sh. I don't want that to be served, and I'll just serve this new folder. I'll call it, what am I going to call this? I guess we'll just call it files. And I'll serve everything in that files directory. So I'm going to do the current directory. I'm going to open up this in bash too. So this will open up in my Linux. So you can see like all I did here was if you don't have Windows Subsystem for Linux, this might not work, but I'm just running this in Linux now. And so I'm going to have this relative directory here, slash, or not relative. No, I'm just going to do this normally. So I'm actually just going to copy this entire, I'll make it an absolute directory. I don't know how relative directories work. I've never tried it. And I don't want to simply go ahead and try my hand at it, even though I've never tried it. But I'm just going to do this. I'm going to copy this directory. And so this is the directory to my like my web like thing that I want to share. And then the default directory for sharing through, remember, once you have your, like, you remember the same thing here, like you have your host thing and then your container thing. Think of it like that. So I have my host mount here, and then now I want my container mount. So by default, the NGINX web server, or like the NGINX default image serves things through the directory in its container / user. So it's work. So think of it as its work directory is /user /share /NGINX /HTML. So this is the route within the container that will be the same thing as this directory. So it'll like this will be a complete mirror of this, if that makes sense. Like this directory in our host system will be a direct mirror of what will be inside the container of this directory, or this container's directory at this exact place. And then the last thing is just the image name. Remember, so these are all just options. And like these are all options. And then if I were to get rid of the option, the last thing that remains is the image name. So I'm going to run this. I'll run this in Linux. And so what I'm going to want to do is just do chmod +x run.sh. What that lets me do is just make this sh file an executable. And I'm going to do run.sh now and see if it works. So it's probably going to have to pull NGINX. Oh, it didn't. Okay, I had NGINX. But if you were to run this exact thing, you should see it working. So I actually forgot to do something. I forgot to make this /files. I want to serve it at here so that the root of the directory, if I were to go to localhost :8080, and I'll show you what that is, it'll serve this as its root. So I'm actually going to Docker. So to stop a Docker process in your console, do Docker PS. Look at its item or its ID. So it's kind of small. There we go. That's a lot better. So I'm just going to copy this ID. Okay, I'll just remember the first three things. It doesn't matter. So just do Docker stop 1366. Hopefully that works. Yeah, so it'll stop it. And if I were to do Docker PS, it's not stopped now. So now I'm going to remove 1366 because it is a stopped process. If I were to do Docker PS all, yeah, the only thing that remains is that thing that I just ran 18 minutes ago. So I'm going to run that executable again, or that shell file. And oh, I forgot to save it. Gosh darn it. Okay, but I'll show you how to do it through Docker. Yeah, so you see the container name is now web. It's not like a randomly generated thing. And it's running on port 8080. I'm going to just quickly delete this. Yes, delete forever. I don't want it. And that's how you do it through the Docker GUI. Again, I don't like it, but it's simple at times, but no, it's not always simple. But so I saved that. Losing my voice here. I haven't talked this much in a while, but right here, yeah. So that I saved the file. I just deleted it because I didn't save it. So I'm gonna run this again, and it should run just like that. You should see a new thing running on port 8080. Now, how do we access that web server? I'm going to go over to my web browser, go to localhost :8080, and you can see that's my website, like that same HTML file. It's running just like that. Let me close out of this console. And you can see that now if I want to change my files, like I'm going to say, welcome to my, I'll just say, welcome now. In real time, if I just saved it, you can see it'll change instantly. And just like that, it's pretty good. It's very nice. If I were to add a new file here, like in my directory, let's call it test.js, and I'll just do some like console log hello world, and then I'll refer to it here. And I'm just trying to show you that like other files work. And then I'm just going to close this off. If I did that right, I don't even know if that's how you do it, but if I were to refresh it and look at the console now, right? You can see hello world there. It obviously recognizes that there's another file in this directory. So again, this would be the same as slash. And if I were to refresh it, it would work the same way. If I were to go to /test.js, go directly to that static file, you'll see that this file is can be changed in real time, just like that. So it's pretty nice. So that's pretty much the essence of bind mounts. I'll show you what this D thing is, the daemon. So let me kill this process. I'll just kill all these, get rid of all these. And then I'll run, I can run this in Windows now just so you guys can see. F10, and then I'll get out of here and I'll do the same thing here, right? And I'll just show you, now I'm in my Windows, kind of my Windows, what's it called? My Windows command line now. And so I just have to change a couple things. So it'll just be for me, since this is a container mount, it would just be /users/main/desktop/website/files. And then I'm also I just wanted to show you how the daemon works, right? Boom, just like that. I have to change the, I'm trying to think what's an easy way so I don't have to. So where does this look? Oh, I forgot. It's not, you have to put the C here. I forgot. Right? Oh, I have to get rid of this now just because I accidentally started. Yeah, you can see it's errored, or whatever that orange symbol means. I'm going to run this again. How much battery do I have left on here? Okay, it should be fine. I'm going to run this again without this, remember, without the daemon flag, without the /D, and you'll see it doesn't actually close out. It actually stays outputting. So you can see I can't really do anything in this console. The live console is being piped into this, the live output of that Docker container is being piped through here. So it's actually being run straight from this process. So if I were to go and show you, we're running short on time here, so I'm probably, I'll try to find it real quick. So if I were to go to Visual Studio, you can see that within Visual Studio, I'm running the Docker executable right now. And if I were to press end task, it would probably kill it. Yeah, it just killed it. So it got the signal to kill, or whatever sign, whatever that signal means. But it pretty much kills it. It was running straight on this console. And so that's pretty much how you run it. But you know, obviously you don't want to do that. But it's good for development, right? If you don't want to running in your background, you have your live console output there, so you could keep it as a reference. So I'm going to do the last example here. So before I continue, any questions, please let me know. It can get complicated sometimes, and I don't want to just gloss over anything. Okay. Do something real quick here. And I'm going to go over to, one second. I have to get this URL ready. So again, interrupt me. I have to do something real quick here. I have to get this URL. So I'm gonna get, so we're last example here. I hope you understand how like Docker kind of works. Hopefully, I'm gonna do a, let me move this down. God, that's annoying. Our last example, I was gonna try to build our own, let's call our own like kind of backend application through Docker Compose, but I didn't have enough time to do that. I'm just gonna use this guy's example. He made an example using Node.js. He made a web server with Node.js and MongoDB. So we're going to be setting up that example. So I'm just going to get that URL. I'll send this to. So here, let me send this. This is the directory. I should just send this. So this is the directory here that we're going to clone. We're going to first clone this repository. If you're on the Linux virtual machines, I actually don't remember if Git comes with it. If it doesn't, just ask. It's just, you would type a command to install Git. I think it's just apt-get install Git, but just ask if you don't have Git. So I'm going to do, I guess I'll create another file here, or another folder, and I'll try to finish on time here at 10. Appreciate you guys sticking around. This is a lot, very long, 2 hours. It's a lot. Okay, so I'm gonna do Docker, I'll just call it compose example. And this will just be a new folder on my desktop. And just like that, I'm gonna go over here and I'm just gonna open this in command prompt. Oh my God. Okay, I'm gonna open this in terminal, and I'm just gonna do git clone, and then that GitHub URL. So this guy Einsteinish, he made this Node.js MongoDB Docker Compose thing that we're gonna use, and I'm just gonna clone it, and oh, I have to CD in there, so I'm gonna CD to that new clone thing. And I'm going to open this in Visual Studio. And we're going to be building this thing, and I'll show you how like the mounts work and whatnot. So pretty much what he does, the author of this, he has a Docker file, and this allows us to, well, what this Docker file does, if you have experience in Node.js, what it allows you to do is, or you can use Node.js, right? And so with Docker, you need a package.json that's kind of like your manifest file that has all your dependencies in it. And you copy these files into, I guess, how does copy work? I've never actually used copy, but I guess you copy those files into this directory, into the current directory, which I'm assuming is /app. I think, I don't know, but you're just copying the dependencies, the dependency files, and then you run install. So what run does is it's kind of like command, but it just, you need to, like, run is just a shell command. It's pretty much just, if you run, it says like, execute any commands on top of the current image. So it's just kind of like running something as opposed to command. It actually does stuff with the output. Yeah, it says provides default for executing a container. So it's like actually, but running is just, again, it's not like the output of running doesn't really matter, and the code doesn't stop there. So that's how he built this. He's just copying these files, and he's also copying all the source code here. So he manages it through there. And Docker Compose, what Docker Compose is it pretty much Everything of this application is defined in this YAML file. And YAML is kind of like I don't know how to explain it. It's kind of like JSON, but like it's kind of weird. It's kind of it's up and coming, I guess. But it's all of this entire application. Oops. And this entire application can be built and run upon this single Docker file. Of course, you need the source code, right? But you have the node service, which is just what he calls it. He calls this Mongo 2. The images gets built upon runtime, and I'll show you how we compose, pun intended, this project. So all it is well, remember what he's doing is he's running port 80 on our host machine. I'm going to get rid of, this is still running. I'm going to stop this. And port 80 is like the default port. I'm just going to do 8080, just so it'll use the same port as what we just used. And the volumes, oh yeah, I guess, okay, so actually I had this wrong. So he doesn't actually copy this volume. The volume is passive. So the volume is a bind mount. So the code itself can be changed in real time. So there's multiple ways of doing things in Docker in terms of like code changes. So I remember someone asked, like, what if you change the Python file? You can actually change the JavaScript file and restart the container, and you won't have to build it again, which is the beauty of it, right? You don't have to, it's pretty nice. So what I'm going to want to do is I'm just going to want to run this. So to run a Docker compose file, you have to be in the same directory as your Docker compose YAML file. So I'm just going to show you that I'm in that same directory. Am I not? Oh, it's like that. Okay, never mind. But, oh wait, it wouldn't even be like that. It would just be like this. Yeah, so you have the Docker compose file here. So what you're going to want to do is Docker compose up/d. And so you could do up and all the output of both of these containers. Remember, these are two containers. So I didn't even explain that. Sorry. Let me go back. So Docker container or Docker compose works like you have a services, and each service is pretty much like a container. So you have your first container here, which is node, which is the source code, and the image itself gets built upon runtime. The Mongo, he uses the image Mongo. If it actually lets me click onto it, and it'll go to the MongoDB, like the official Docker image. He's using the official MongoDB Docker image. And again, this is just a database, in case you didn't know. And so you have two services running within one Docker instance. Well, it'll be two Docker instances. It'll be in the same Docker, of course, but it'll be in its own compose. So it'll be in its own stack. And I think there's let me make sure. You'll see it actually. I'm not sure, but I'm going to do Docker compose up-d, and it'll first probably build, or yeah, it's going to pull Mongo because I've never used Mongo. Let's see if that works. And yeah, just going to let that run. It's building it, or it's first pulling the Mongo image straight from Docker Hub. And again, the code, I can literally change it upon runtime. I don't have to rebuild the Docker image unless I add a dependency, because the only thing he copies is the package.json, right? And the package.json, if you're not familiar with Node.js, it has all your dependencies. So if I were to add a new dependency, it's not going to recognize that change, I believe. Just looking at it, I don't take my word for it. I'm just kind of looking at it, seeing what it is for face value. But let's see here. Yeah, so again, it's using a bind mount, so you could change it without rebuilding the entire image. We're gonna let this pull. Yeah, I guess we'll just let that do its thing. When that's besides, or I mean, well, while that's running it, if you have any questions, I know I just kind of glossed over that, but yeah. Okay. So I just finished that. Now it's, see what it's doing. It's using Node. which I already have Node installed. So it's using, or I don't have Node installed, but it's using Node.js version 12.18.1. That's a pretty old version. I don't actually remember when this was made, but you can see in here on the Docker file, his base image, the guy that made this, his base image was version 12.18.1. And again, after it pulls this Docker, or after it pulls this node image, it'll set the work directory to /app. It'll copy these files, and then it'll run npm install, which installs the dependencies based on package.json. It'll copy, I don't even know what this, it's going to copy everything in our current directory. Okay, so it'll copy everything in our current directory into, I don't even know what this is, to be honest. He doesn't even use /code. No idea. I don't even know, but we'll just see. I've tried this before and it worked. I'm sorry, I can't even explain what his thought process behind using that as a bind mount and then also copying everything in here. No idea, but whatever. It is what it is. That's what happens when I don't get to make my own things. We're just going to let this install for now. Yeah, you can see now it's doing npm install. And so remember, the Docker file is just a set of procedures, a set of instructions, kind of like a recipe. You see it, it actually lists it out as steps. So it just finished running step 5. And now it's running the Docker compose. And you can see it's building a virtual network for Docker compose. And I'll show you how that looks like in a second. It's building a volume, which I don't know the purpose of that. Oh, I'm assuming the volume is for, let's see, actually. So he's using so this is called a, what is this called actually? He's using just a volume, a Docker volume. Instead of using a bind mount, he's using the Docker volume. So that'll actually show up in here. You'll see a volume called MongoDB or something. It's not called that, but it'll be the containers hash that you can see. Yeah, so right here, actually, I didn't even see it. But you see that anything you run in Docker Compose, it's always prefixed with the directory that you're in, I believe, and then the name of the actual thing. So you could see that all my storage from that database is being stored in here in this Docker volume. And you can actually see the data through Docker Desktop. This is the data, and it's kind of exploring everything inside that Docker image. Again, this is not a directory. This is a Docker, I said Docker image, Docker volume, sorry. And this is not a active directory. This is more so like a virtual disk. Think of it like that, if you're familiar with virtual machines. So I'm going to do, I'll show you how this works. And also I'll show you on Portainer, there's an extension here that lets you, that shows you the versatility of this, right? It's insane. So you can actually see when I was referring to it creates its own network, everything inside of services, everything inside of here, like inside of services, inside your Docker Compose, those are, when you do Docker Compose, it'll automatically be in its own virtual network. So what does that mean? You can see if I were to go into networks, and this is just a Portainer extension, you could see there's its own separate. So by default, I believe every Docker container goes to the bridge, which is like pretty much like your network card, like your default one. But the thing is with Docker, you can see that it builds its own virtual network so that each Docker container can talk to each other. That's what that linking that I showed in the very beginning. It allows you to like talk to other. So you can see right here, the node, like this is like the node directory. It can talk. They're in the same network, so because they're in the same subnet, they can talk to each other. Essentially, that's like what I want you to get out of that. And that's kind of like that linking. So I'm going to show you the application now. I didn't even explain what it was. I think all it is just like it's just like lets you store lists. It's just a demonstration for Docker Compose. So again, I ran this on 8080. and you could see, what is that? Let's see here. Do some diagnosis. Message not found. I don't even know what does that even mean? Come on. Might have been because I changed it last minute. Okay, well, we can actually look in the logs real quick. And oh yeah, so you can see right here, if I were to go in containers, there's a stack here or a compose that it has 2 containers within it. So that's like that composition. So I'm going to go over to Node and look at any errors that I have. So it says Mongo's connected. I'm actually going to kill this and redo it. I think I'm just going to use the default ports and stuff. Oh, so it uses, that should have worked. I'll just do, what was it by default? I think it was 80. I'll just use port 80. Yes, okay, so I just deleted everything. I'm gonna do the same thing I did before. And this time, I'll make, actually, no, I'll just daemonize it anyways. So because I have everything set already, it's just gonna do this again. It'll just, it should be really fast. You saw that it literally took like 5 seconds to run because everything's built already. So all it's doing is just deploying the containers, which is a very fast process. And it's also building the virtual network. Now let's see if that fixes it. And I'm gonna go to port, just localhost. Okay, that's really bizarre. All right, don't wanna figure this out right now. I have it working on my main computer. 1 second, I'm gonna switch. Okay, and I'm gonna go over to here, share my screen here. You guys can see my screen. I was doing this earlier, so Docker PS. So this is like one of my servers that I was running. I have a ton of other stuff running. So I'm gonna do Docker, let's see, ls Docker run, and also this might be it. Docker compose. I changed the port to 1520, and I also changed this to Mongo 4.4 because the version of, or there's some hardware issues running it on the latest version, which was like this, but I changed it to version 4.4, and I also changed the port to 1520 because I have stuff running on all those other predefined ports. So make those 2 changes if you want, and then I also made this version 3. I don't really know, but I just made a 3, and version 4.4, 1520 right there, boom. Change those, and I'm gonna do Docker. I'll leave that up actually. I'll do, actually, I don't like that. Then I'll do Docker compose. Oh, didn't mean to do that. Docker compose up/d. And it should be really fast. Now I'm gonna go over to, let's see if this works. So I'm gonna go over to, what is this? I forgot what this is. I think it's server1.zavar.net. This isn't gonna work for you. This is just my own internal servers. Colon 1520. See if that works. Yeah, that's really weird. I literally had it working before, but what it was, if it did work, sorry, it's not working, but it allows you to just add stuff to a list, and it'll save it. That storage was persistent, and it would store it to that Docker image, or that Docker volume, sorry, for MongoDB. So it was just kind of like you have your Node project and you have your Mongo project all in one Docker composition, and it works just like that. That's pretty much what it was. I'm sorry it's not working. I have no idea why. I literally had it working on this machine, like when I was testing it before we started. Don't know why it's doing that now. Let me check actually. Is it running it already? It's not. Okay, whatever. That's pretty much all I have. Sorry it didn't work again, but take my word for it. That's what it was. It just lets you add stuff to a list. It was pretty, it was there's not much to it. That's all I have. Thank you guys for sticking 2 hours. Man, that's a long time. But yeah, any questions, let me know. I'll be here for like a couple more minutes after. And you're free to go, I guess. I mean, you're free to go whenever you want. I'm not your parents. But yeah, thank you once again. Hopefully you guys use this stuff. It's very powerful stuff. It's very good to put on your resume. It's very profitable skill. It's very popular too. I can actually show you. I was looking the other day in trends.google.com. Like Docker is like getting very popular software in the past like 5 years. It's okay. That's not that good. That doesn't look, but it is getting better. I'll show you like from 2004. Yeah, it's getting pretty popular. At least Docker, the software, but containerization is a very important tool in DevOps and when you're deploying code, and for system or like for architecture when you're like at a very high paying position at your job and you need to be able to make your application stay on with very little to no downtime. Docker is a very good tool to achieve that. So I thank you guys for sticking around. Appreciate it. That's all I have for today. I'm sorry it didn't work. And yeah, let me know if you have any questions. Otherwise, that's it. That's all I have.